Okay, welcome to Sairam Triple YouTube channel. Let us discuss first module, that is DC circuits. So as you can see the diagram, there is a battery present and one lamp will be present and one switch will be there. So in this we can consider this is a resistive load and then this is a battery. So I told you already, I have given example. Just to consider, this one is a battery of your bike and then this one is a lamp, right? So if we, I think in your bike there is a switch is available in the handle. Just to press, definitely lamp will be glowing, headlamp, and then if you close, definitely it's open. So current will not be flowing from source to the load. So that's why it's a DC circuits. Okay. So this is the best example for your DC circuit module, that's a battery and bike headlamp. Okay, so in this module we are going to discuss Ohm's law, Kirchhoff's laws, analysis of series and parallel circuit, and series parallel circuit exerted by independent voltage sources, power and energy, illustrative examples we are going to solve now. So in one word, I can name Ohm's law. I is equal to V by R, current flowing through the conductor directly proportional to voltage, inversely proportional to resistance of the conductor with the temperature remains constant, considering two ends of the conductor, right? And Kirchhoff's law, KCL and KVL will be there. Kirchhoff's current law, algebraic sum of the current meeting at a junction is equal to 0, or entering current is equal to leaving current. And KVL, algebraic sum of the voltages around the loop is equal to 0. Uh, it's a complete how much drop will be there, particular electrical appliances or electrical components, that we are going to discuss. Analysis of series and series circuit. If suppose number of resistors are connected in series, what could be the equivalent resistance? So R1 plus R2 plus R3. Parallel resistance circuit. If suppose number of resistors are connected in parallel, what could be the equivalent resistance? So series parallel circuit excited by independent voltage sources. So if you connect series resistance and then one two parallel resistances, that becomes a series parallel circuit. So power and energy. So power is work done by unit time, right? And energy is equal to power into time, right? So even though there is a equations present. Okay. Ohm's law, current flowing through the conductor directly proportional to voltage, inversely proportional to resistance of the conductor with temperature remains constant, considering two ends of the conductor. See here, just you consider two ends, okay, here and here, then only it is applicable, otherwise it won't be applicable to in the any of the electrical circuit. We should consider for only this one circuit which is having two ends. If you place one wire, copper wire, into another end lead wire, or if you join together, so sometimes it will get melt, right? So as you can see the diagram, this is a Ohm's law triangle, analogy, okay, and this one is a one logic, just you consider. So voltage is a pressure, so current is here, and then the Ohm's law, resistance. So if suppose somebody is pulling, so what happens, the current will be flowing decreases, right? I is equal to V by R already, so I told you, if suppose voltage increases, current increases, right? And if suppose resistance increases, what happens, it's a indirectly proportional, definitely current will be decreases if suppose resistance increases. See, if suppose this wire, this rope will be there, right? So the person is pulling over here, and if suppose increases that resistance, what happens, current will be flowing reduces, right, from here to here. So pressure will be there, voltage, but it will be reduces, right? So that's a one statement. This is a basic for your throughout engineering life. So if suppose somebody will ask you, state the Ohm's law, please at least um, you should have a capability to answer. I is equal to V by R, current flowing through the conductor, just to consider on a conductor. So it's directly proportional to, just to consider resistance will be there, okay, directly proportional to voltage, so voltage this one, and inversely proportional to resistance, this resistance. So considering two ends of the conductor AB, okay. So this is a statement of Ohm's law. Next we'll move on to the limitation. So I'll be giving some overall explanation, because you should not forget this Ohm's law concept. See here, here there's a water tank is filled with full of water, right? Here there is a tap is closed, isn't it? So if suppose tap is open, what happens? So this water will be flowing here to here, here to here. Just to consider your home, okay? There is a tank present in the terrace, like top floor, at the top of the building. So if suppose if you open the tap, the tap has a resistance, and this pipe is like a conductor, okay? This is a voltage, whatever the head we are creating, right? Then you might have got a doubt, right? Might have asked me the question also, like, sir, why we need to keep the tank at the top? Because to increase the pressure. So I told you voltage is a pressure, right? So that purpose we have a tank at the top, right? This is a resistance. If suppose you release water, that is a less resistance, yeah, like this. So water will be flowing here to here. So this is a current, okay? This is a conductor. Whatever the water is flowing, right, there is a current. So as you can see the diagram here, there is a normal pipe. This one is a tilted pipe over here. So if suppose resistance increases, current will be decreases. This is a concept. And next there is a limitation of Ohm's law. Okay, limitation of Ohm's law. So Ohm's law is not applicable to nonlinear devices such as diode, semiconductors, and transistors. Why? Because I think in the motherboard of laptop also we can see there is a heat sink material. Why they'll keep heat sink material? Why the heat is produced in the electrical appliances? Because of this semiconductor transistor and gen diodes. Because if suppose current increases or whatever, what happens? That uh, resistivity will be decreases. I mean, if suppose temperature increases, so that's why we are getting heat in the electrical appliances. Even though if suppose any fault occurs, if suppose your mobile charger is not working, or if suppose hair dryer is not working, definitely diode is will get burned. Because if suppose current is maximum will flow in the diode, so automatically it will get burnout. Easily it can heat up, okay? It is not applicable to non-metallic conductors such as silicon carbide and liquid conductors, and also gallium arsenide, okay? So it's a liquid conductors. For example, I'll tell you, if suppose if you pass electricity to the seawater, everybody knows, right? From the childhood days, seawater is a good conductor of heat and electricity. If you pass electricity into the sea, so we cannot predict, right, where exactly electrons will be flowing. So that's why it is not applicable. And it is not applicable to arc lamps. So I think you might have seen, right? If you switch on the power supply, it will be glowing after 2 minutes or 3 minutes. So that's why. So the temperature reaches some limit, then only it will glow. So the statement itself tell about us. So it is not applicable to temperature varying devices. Temperature remains constant, right? It does not holds for good temperature varying devices. So thermistor, thermocouples, there also it is not applicable. And also the final point, it is not applicable to circuit having more number of branches and then nodes. See, I think everyone will mm, having doubt in your mind. Why, sir? Ohm's law is past. Why not KCL KVL? So to solve that problem, we have a Ohm's law. KCL KVL. Ohm's law is for only normal circuit, not complicated circuits. So if you want to solve complicated circuits, there is a KCL KVL. If suppose KCL KVL is not applicable, too much of a complication, we have a theorems. So there we are going to solve whatever the electrical circuits networks, right? So that's a major topic. So as you can see the diagram here, so it at least it's like it's in corner, okay? So it's in corner. So just I'll draw over here. This is voltage, this is current, and this is straight line linear, okay? If suppose any difference occurs over here, any deviation will be there, means Ohm's law is not applicable. Keep it in your mind. This is voltage, this is current. So voltage increases, current also increases, but resistive decreases. If suppose any difference will be there, Ohm's law is not applicable. So deviation will be there, Ohm's law is not applicable. I told you, right, why genodiode is not applicable. The characteristics curve is like this. Why diode is not applicable? Characteristic curve is like this, exponential. So if suppose difference is there, I mean like deviation is there, it is not applicable. Okay.